Okay, the first thing that we'll be talking about today is the law of superposition. So, super important to put this down. The law of superposition states that the older rocks will be at the bottom layer and the younger rocks will be at the top. So, if we think back to when we were talking about sedimentary rocks and how little sediments will be carried away through weathering or erosion, they'll end up somewhere and settle down, like let's say, for example, at the bottom. And then years and years later, maybe like water will bring a different group of sediments to this area, and then it'll stack on top, and then they'll keep on stacking on top and on top of each other. And so that's why the at the top that would be the newest and the youngest rocks. So if you ever to get a question that asks like if you found a fossil, which layer would likely be the oldest, or be the most bottom layer? So that would be D, because of the law of superposition. And the opposite of that, if you found a fossil, where would it be the youngest? Uh, then it would be A, because those were the new rocks that just arrived and stacked on top. So this is 3.3. We're on a new section called geological time. So let's say a scientist finds an ancient fossilized fish in one of these layers. What's most likely true is what we just talked about with sedimentary rocks. They form layers and keep on stacking on top of each other. So most likely they'll have some type of sedimentary rock. So let's say the fish died and its body is there, and then let's say a river stream carries a bunch of sediments over to the fish and will slowly cover up the fish. So a little bit of sedimentary rocks will cover up the fish, then stack on top of each other, and then they'll keep on doing that. And then the fish will just stay in one of the rocks. Okay, I got a question from one student. So how old would a rock in A be? It can be, so we know that it'll be the least amount it'll be the youngest. So it can even be recent, right? In A, it could be 100 years, it could be 10 years, 5 years. Guess depending on when the most recent layer just arrived. But the lower ones, the more lower we go, it can be like more thousands, more even 10,000s, the deeper we go. So that's why like sometimes we see paleontologists, they would try to dig as much further down as they can. And how deep they go, they can kind of have an estimate on how old or what time period these fossils are from. So I can't give you like an exact answer, but I'll say like 100, less than 100 years at least. Because they vary, right? They vary based on how the sedimentary rocks stacked on top. So this might give you a better um, idea of like how old these fossils might be. So move down a little bit. So first, we'll go over the geological time scale. That's what scientists use to measure how old the Earth is and how long ago fossils might be. So I'll go back to the notes, but let's just take a look at a timeline of our Earth. So if we start at the bottom, it's just like the Earth is formed. And these are like millions and millions of years ago. And then slowly we go up, more animals are formed, more life forms. And there's a lot of names to remember, but first we'll just focus on a couple. And first we'll focus on how we measure these time. So the first unit of time that we use to measure for the time scale, that's eon. Okay, well, we can put this down. Can I go up a bit? Yeah. So eons will be the largest, and then eras, and then period. So the division of time on this geological time scale that's the longest would be eons. And eons are like billions of years. So like this one period is like 1 billion, more than 1 billion years. And we have like, it's broken into like four. So we have like four different types of eons. I'm going to move this up a little bit. So yeah, eons, 1 billion. Let's see if we can bring up the other ones. And then we have eras, which are longer than periods. I know there's a lot of names that you need to know, but mainly eons, which is the longest one, and then eras and periods. And you just need to know that eras are longer than periods because eras are like 700 million, and then periods are just 1 million or 100 million still, but just one of them. So then a statement that would accurately compare the two divisions of geological time would be that eras are longer than periods. Give you one more minute to write this all down. Then I'll move it down a little bit more. Okay. So one time scale, one tiny division of the time scale that we would, let's go here, that would be the one Cenozoic. It's not even listed in here. Oh, it's right here. So one era that we need to know about is the Cenozoic, which is the the most recent one. If you see the span, it has been 50 million years in this time era. And then it's in this eon, the Phanerozoic eon. But this one, the Cenozoic, includes the rise of mammals and rise of man. Humans and a lot of mammals that we know nowadays that we see were formed. Yeah. So that's the most important one that we need to know. The most recent one that we're in right now, the Cenozoic. We're almost done. Let me just. If you need the front part, I'll put it up later. I'm just gonna continue to add on. So one theory that's brought up about the Earth catastrophism. Okay, so if a student suggests that all of Earth's changes happen very quickly, uh, so an example of catastrophism is back in the dinosaur era and an asteroid came and just hit the Earth, caused a huge mass extinction. So right in a like in one moment, like the Earth completely changed. And so the idea behind to describe that is catastrophism. So kind of like a catastrophe, right? A disaster. So that's where it got its name. And then the opposite of that, uniformitarianism. That describes the idea that Earth's landforms change at a constant and steady rate. So let's say how we've been learning about weathering and erosion, how the water, let's say like the river, like shapes the rocks that it would pass by. So that's something that happens slowly over time. It's not something that just breaks off the rocks right away. Or when like islands are being formed, when they're being deposited, sediments are being deposited somewhere, it'll be like a slow, gradual process. Like an island isn't just going to pop up right away, it's just going to be slowly built over time. And you look at the root of this word, like uniform. Uniform means like the same. It's like how you have uniforms and all the clothing is the same. So the change in these Earth's landforms would have the same rate. And then two statements that help support excuse me, uniformitarianism is that Earth's surface changes slowly and constantly, because we witness that. We see a lot of mountains like slowly chip away through weathering, like let's say rain. And some of the processes that occur today also occurred in the past, which shows that it's still happening. The change is still slowly happening. So, like weathering that happened back then, right? There was always weather, like rain to chip away the rocks, or there were still river streams to change the rocks that it would pass by, or ocean waves. Like that's always been there, and it's always been causing a change in the Earth's surface. So I'll go back to the notes, but I'm just going to show you a quick video to kind of like summarize and wrap this up. And after this, we can do our independent work.
What's the geologic timescale? Well, the Earth is old, really old. It's so old that it's had 4.6 billion birthdays, but it doesn't like to talk about it. People called geologists have counted up all the birthdays and made a big fancy chart to help remember them all. It's called the geologic timescale, and it's one of the most important things you need to know when you start to study geology. 4.6 billion years is a long time. Let's say this represents 100 years, or about a human lifespan. That human lifespan is only one pixel if we zoom out to 100,000 years. We then need 10 of those to get to a million years. To get to a billion years, we'd have to add that up 1,000 times. That's a really long time. There are so many Earth birthdays that we have to arrange them into phases. These phases are sometimes called eons. The eons are broken up into eras, which are broken up into periods and epochs. Geologists are apparently fond of words that start with the letter E. The first eon is called the Hadean. It's about 500 million years when the Earth is just a hot ball of rock, and the Moon is forming. What's up, Moon? Next is the Archean. Everything is chilled out a bit by now, and the continents are forming. This takes a really long time, almost 1.5 billion years, and life is starting to form in the oceans. As the Archean is ending, that new life starts to fart out oxygen into the atmosphere. After that is the Proterozoic, which means early life, but it really means very small life. During the Proterozoic, we get the first complex cells and the first things that are made up of more than one cell. The Proterozoic is also very long, about 2 billion years. As the Proterozoic is ending, we get the first plants and the first animals. The final eon is called the Phanerozoic, which means visible life. It started about 500 million years ago with an explosion of new and crazy looking living things, and continues to this day. It's divided into 3 eras. The first era is called the Paleozoic, which means old life. But what it really means is squiggly life, or weird wormy life. It also means creepy crawly life. Mesozoic means middle life, but it really means dino life, or life that goes roaring. The Mesozoic ended with a giant asteroid that killed almost everything that went roaring. The third era, the Cenozoic, means new life, but it really means furry life and flappy flying life. We also got pretty looking things that bloom. There's lots of different furry and flappy things. There's things that go blub, things that squawk, and things that go awoo. There's also new things that roar, but they're much fuzzier than the old ones. That's the geologic timescale. Some say that humans have changed the Earth so much that we've entered a new period of geologic time called the Anthropocene. More on that next time.
Yeah, I'll go back to notes after this. Yeah, here are the notes. If you're done with your notes, go ahead and do your independent work. So that would be 3.3, the quiz today. So just a reminder, student parent conferences will be this week. So there's still time to get your grade up. If you have missing quiz scores, that's going to bring your grade down. So let's try to do those. If you don't finish in time, do it for homework